All right, so welcome to the matter and energy review. I am going to go over these practice problems so that you can help with your test. I'm going to use my little handy dandy little writing tablet. And thank you for joining me. All right, so let's start taking a look here at some questions. So question number 1, which statement describes all compounds? Right, so it says all compounds, right? So making sure that we're looking at the word all. Let me get a drawing over here. Ready. Let's use purple. All right, so all compounds. So all compounds don't contain 3 elements because some contain more than 3 or less than 3. You don't know anything about bonds yet. Can they be decomposed by physical means or decomposed by chemical change? So compounds can be decomposed by chemical change, right? We can take a compound and we can split it down into its elements. All right, so question 2 says, how many joules of heat, right? Who wears the joules? The queen wears the joules. So that's telling me I need to use this Q calculation. And we're going to do Q equals MC and change in temperature. So we want to raise the temperature of 4-gram sample. So then that means I have 4 of water. So that means I need to go to reference table B to get the specific heat capacity of water, which is 4.18. And that's a 4.18, sorry, and 8 degrees Celsius. So that is the temperature change. So then I multiply those 4 numbers across and I get 134 joules. Right, so you need to go to table T to get the formula and table B to get that C value of specific heat capacity of water. All right, at which temperature does an aqueous solution of LiCa have the highest average kinetic energy? So average kinetic energy means temperature. So let's try that question using the word temperature instead of average kinetic energy. Which one has the highest average kinetic energy? Well, I have Celsius and Kelvin temperatures here. So I need to compare them all using the same value. So I'm going to go to table T and I'm going to get my Celsius is, oops, sorry, not Celsius. Let me erase. Apparently, there we go. It's been a while since I've used this thing. All right, so our Kelvin is equal to the Celsius temperature plus 273. So our 100 degrees is actually 373 Kelvin. Right, and so now I have 3 numbers in Kelvin and 1 in Celsius. So then 273 plus 200 is 473. So which one is the highest is going to be D, 200 degrees Celsius. All right, which one is a homogeneous mixture, right? Our prefix homo means everything is the same. So here I have a compound and I have water, right? AQ means aqueous, which means water. So that all makes that a mixture. This is just liquid water, solid, whatever that is, and gas, whatever that is. So those are compounds, and A is your mixture. So only one of those was a mixture, and it's homogeneous. All aqueous solutions are homogeneous. Okay, so which one could be heterogeneous? So that is going to be a mixture. A compound is going to be homogeneous, and so will an element. And a solution is also going to be homogeneous. And then just for the sake of not writing out, I'm just using the prefixes so that I don't have to write out those giant long science words. All right, if I have a pure substance is an element or a compound, E or C for element or compound. So then here, that means everything has to be the same in the box, right? Pure means everything is the same in the box. So the only one where all the pictures are the same in the box is this one. So this one is a compound. This is a mixture of 2 elements. This is an element, this is another element, right? This is another mixture of 2 different elements. And this is also a mixture of 2 different elements. So I have 3 mixtures in 1 compound. Now during a chemical reaction, the law of conservation states that matter and energy are both conserved. Right? That's just a memorized thing from your notes. All right, so now I need a mixture of an element and a compound using my key here, right? So I have one atom of an element and a different element. So I want an element and a compound. So this is one element This is a different element. That's not an element in a compound. This represents an element. This also represents an element. Remember, you have two different pictures stuck together to make a compound. This is just one compound. These are all the same in a box. This is not even a mixture. And so here I have an element and a compound. This is a mixture of an element and a compound. All right, so here I have an image and I want to know which one describes the same substance. Remember, you have to read chemistry questions very carefully after a physical change. Remember, physical change, no new substances are formed. That's how I know something is physical. So that means that I still have to have the white circle, black circle stuck together. The only one that has them all stuck together is A, right? So this one is a chemical change, made a new substance. All right, so then now I have how many kilojoules? Now, who wears the joules? The queen. This says kilojoules, so be very careful. To raise the temperature of 500 grams, that's a mass, from 15 to 20 degrees. So I'm going to do my Q equals MC delta T, right, from table T. And I'm looking for the Q. And the mass is 500 grams. The specific heat capacity, right, I got to go to reference table B, and that's going to be 4.18. I know that looks like a 9, but I swear it's a 4. And now the change in temperature is from 20 to 15 to 20, right? Final minus initial. 20 minus 15 is 5. So I multiply that 500 times 4.18 times 5, and I should get a calculator, and I don't have a calculator. So the answer is going to be 10.5 kilojoules. So that means it's going to be 105. And then 1, 2, yep. So this is the number you should get on your calculator in joules, right? But the question wanted kilojoules, right? So then kilojoules, right? Joules on the bottom, kilojoules on the top. According to reference table C, kilo is 10 to the power 3. So that means 1 kilojoule is 1,000 joules. So I divide by 1,000, which is going to be our 10 point. That's where the 10.5 comes from. So this question you had to read really carefully because it said kilojoule. So I wanted you to go one step further. Okay, so recovering the salt from a mixture of salt and water could be best accomplished by evaporation. If I filter it, both are going to go right through the filter. I can't separate them by density because they're dissolved. All right, which describes water in this liquid phase and hydrogen peroxide in its liquid phase. These are two different compounds. Both are compounds and they do not have the same properties. Those are compounds that have different properties. Yep, that's true. Both are mixtures. Nope, those are pure substances. So B. All right, so which statement explains why NABR is classified as a compound? Well, it's because I have two elements chemically combined. Dissolving, nope. Solid, nope. Chemically combined in a fixed proportion, yes. All right, which substance can be decomposed by chemical means? That is the definition of an element. And I know that I can find all of the elements on table S of my reference tables. So then now I need to go to table S of my reference tables, and I'm going to find which one of these is an element. So this is, I'm sorry, this is the definition of a compound. Oh, sorry. But I still need table S, right? Because it can be, elements cannot be. This is why we need to read really carefully, because sometimes my brain goes too fast. Slow your brain down, read carefully. So all the elements are listed on table S. This is krypton, that's an element on table S. This is zirconium, that's an element on table S. This is cobalt, this is an element on table S. This is methane, it is not on table S. This is the compound, methane. The other three are elements on table S. All right, so then which Kelvin temperature is equal to negative 73 degrees Celsius? Well, from table T, Kelvin is equal to Celsius plus 273. So my Kelvin temperature is equal to negative 73 plus 273. So then my answer to that one without, so I didn't even bring a calculator with me to the computer. So that's shame on Mrs. Davis. That's going to be 200 Kelvin. A sample of unknown composition was tested in a laboratory. The sample could not be decomposed by chemical means. I didn't mean to scribble that out. I really just meant to circle it. So that's the definition of an element. Which substance cannot be broken down by a chemical change? Now, this one is the opposite of the previous question that I didn't read carefully enough. Element, that's the definition of an element. So again, I need to go to reference table S. So ammonia is not on table S. Methane is not on table S. Argon is on table S. Water not on table S. This is our element on table S. Okay, so here I have a potential energy diagram, and this is exothermic. And how do I know that? Because I went to my notes, and this looks like the picture of the exothermic curve on your notes, right? There's two curves. One is endothermic and one is exothermic. So which one of these? This is going to be exothermic. So I'm going to cross off my endothermic choices. And now the delta H, remember from our notes, for exothermic is going to be negative because it means heat is going out, and we use the negative sign to indicate heat is leaving. And remember, the bottom of table I, the fine print, says that the negative sign is exothermic. So exothermic. All right, so here I have another one of those diagrams, and I know from my notes that this is endothermic, right? You should do questions using your notes. All right, so according to this diagram, it's endothermic, so I'm crossing off my exothermics. And then endo means heat is going in, and our word for going in is absorb. And so it absorbs energy. Which statement describes the components of a mixture? Each component loses original properties? Nope. Each component gains new properties? Nope. The proportion of the components cannot vary. That's not true. I can make a mixture and I can have a little bit or a lot of the different substances. I get to decide. So the proportions can vary. Yes, that's your answer. All right, so a solid A is at 80 degrees and it's immersed in a liquid at 60 degrees. Which statement describes the energy changes, right? Heat always goes from high to low temperature, right? That's the direction. So I'm going to go from solid A to liquid B. So A releases heat and B absorbs heat. Yep, because if it's going from A to B, A is going to release the heat and then B is going to absorb the heat, right? One loses and one gains. All right, so number 22, we have a 500-gram sample of water at 19 degrees and it absorbs 8.40 kilojoules of heat. The temperature of the water will change too. So it looks like I'm solving for the change in temperature or the final temperature. Which one? It's going to be the final temperature. I need to find my final temperature question. So I'm just going to do this down here at the bottom, right? Because I need to do my Q equals MC delta T, right? Because I have joules. But notice that that says kilojoules, right? So that means I have to convert my kilojoules to joules, right? This is why we did the metric conversions unit in the first unit. So I have 8.40, I have kilojoules, and now I need to convert from kilojoules, goes down to the bottom to get rid of it, to joules, right? Because kilo is 10 to the power 3. So that means 1 kilojoule, because it's the bigger unit, so it gets the number 1, is 1,000 joules. So I multiply that by 1,000 to get 8,400 joules. Okay, so now let's go through, and now I know my Q, right? Because the joules. So I have 8,400, and now that equals M, which is mass, right? From my question, right? Mass measures in grams. And again, didn't mean to scribble that out, but that is 500. Let me just erase that so that it doesn't look terrible. Here we go. Okay, so 500 grams. Now I have the specific heat. This is water, right? Because it says water in the question, which means I go to reference table B and I get the number 4.18 for the specific heat capacity of water. And now I have the change in temperature part. I want the final temperature. So that's final temperature minus the initial temperature, which is 19 degrees. Okay, so I walked through a bunch of these already in class, but now I'm just going to go through. I want to get rid of the 500 and the 4.18 because that's multiplied towards my x minus 19, right? So that's going to be my first step. And I do the same thing both sides, right? So then I have the 500 and the 4.18, right? So then that means that I have 8,400 divided by 500 times 4.18, and that equals x minus 19. All right, let me just grab a calculator. It's not really a calculator. I'm just going to use my phone calculator. Okay. All right, so I'm going to do 500 times 4.18. So that is equal to, I have 8,400, and then that is going to be divided by 2090. So then I take the 8,400 and I divide it by 2090. So that's equal to 4.02, and that equals the x minus 19. So I still need to get x by itself. So I add 19 here, and then I add 19 here, and now I add 19. And so I should get 23.019, so 23 degrees. All right, so 23 degrees. Okay, so also let's think about it like using like logic instead of math, right? So if I have a sample, it's at 19 degrees and it absorbs heat, okay? That means the temperature should go up. Your temperature should increase. If I start at 19 degrees, it's not going to stay at 19 degrees. The temperature is not going to go down. The temperature is not going to go down. So can you solve this question without using math? In this case, you could, just by knowing that absorbing means the temperature is going to go up. Okay, so let's look at number 22. Which statement is an identifying characteristic of a mixture? A mixture consists of a single element? Nope, because that would be a pure substance, so not that one. A mixture must have a definite composition by weight. Definite means does not change. I don't really like that because I think that a mixture, I can change the proportions or the composition of a mixture depending on how much of each substance I put in. A mixture must be homogeneous. Nope, it could be heterogeneous too. A mixture can be separated by physical means. Yes, mixtures can be separated by physical means. All right, so then 2 more questions and then we're done. All right, 2 samples of gold that have a different temperature are placed in contact with one another. Heat will flow from a sample of gold at 60 degrees to a sample that has a temperature of, well, heat is going to go from high temperature to low temperature, right? So if the gold is at 60 degrees from a sample of gold, if I want it to leave this sample of gold, I need to go to a lower temperature. So then the other piece of gold has to have a lower temperature than 60 degrees. It's not going to be the same temperature. And now I have 2 temperatures above and I have 1 temperature below. So it's going to be B. All right, 1 similarity between all mixtures and compounds. 2 or more substances, maybe. Combine in a definite ratio. This is only for a compound. Are heterogeneous? No, because not all mixtures are heterogeneous and compounds are homogeneous. So it's not going to be that one. 2 or more substances. Okay, so thank you for joining me. I hope you find this video of our review helpful and good luck on your test. You should practice these problems because they're similar to the ones that will be on your test. All right, goodbye.